As you see, I'm from IBM, but we have a good relationship with our partners at CA, and they're a great supporter of the Z platform. And in fact, we announced yesterday with Ashok Reddy, who's the GM of the mainframe business, that we have a OEM relationship that we've set up around our IDE. So that's just one of many things we're doing with the folks at CA. Now, I'm from development and product management and that type of thing, and I run a part of the business that we call DevOps for enterprise systems. What it means is DevOps, where we make certain that we treat the mainframe as a first-class citizen, and that we integrate the DevOps technologies that you need for distributed web, mobile, with that, and mid-range with that on the mainframe. And so you think holistically, because enterprise applications are multi-platform, multi-technology. I've heard it said here many times, we say it as well, mobile to mainframe. And there's no reason to be having solutions that are siloed based on where code is going to run in production. When you're doing development, you want to think holistically and work across everything. So that's our focus. Now, what I'm going to speak about today are a few interesting, or what we view as interesting things we're doing around the mainframe, just as a teaser almost, because a lot of people have misperceptions about the mainframe, or Z systems as we call it, and so I just want to put out a few interesting things to maybe whet your appetite. So we always have to have the obligatory motivational slide, and this one is all about huge numbers, huge growth of data, most of it unstructured these days, Internet of Things, devices talking to one another, and so forth. And one that's, I think everybody understands personally, 10 or 15 years ago, you spent next to no time on your cell phone, and now they say the average is 3 hours a day. And we're all guilty of it because there's always something to look at, okay? So there's lots going on. The thing is, this growth is an opportunity, and in fact, we're seeing the reality of it driving a lot of workload growth on back-end systems. Maybe not when you're checking Facebook and Instagram, but when you're actually checking your bank account, of course, that's driving transactions on the back end. So maybe if you're in this area, this is not a very important question to you, but there's a lot of people, I think, that wonder if the mainframe is still relevant, or are there still mainframes out there? And there's a number of people who may not think that the mainframe is particularly relevant, and it's understandable, it's misguided, but it's understandable because if you see that thing on the upper right, and that's the face of the mainframe, that seems pretty outdated. And, or people knew about the mainframe from years and years ago and they haven't heard anything, or their job doesn't cause them to know anything about it. Their view is frozen in the past, all right? Or they just simply have no experience. And unfortunately, some of these folks who might have this point of view are CIOs at companies because they grew up in the distributed age, in the web age. And so the question is, and it's a valid question to ask, is it relevant? And everybody probably has heard about Stuart Alsop and saying 25 years ago that the last mainframe would be unplugged 5 years later. And of course, then he had to eat his words because, 5 years later, 25 years ago was 20 years ago. So, and the fact is, the mainframe is every bit as relevant today as it's ever been, but it's not just for running the things that we think of as the mission-critical workloads, the KICS transactions, IMS transactions, TPF, so you can get your airline flights booked and all that. There's actually new workloads coming as well, and so that's what I'm going to talk a little bit about. Now, just to put things in perspective, here's a few fun facts, if you will, about the mainframe. And it's of course a great platform for efficiency. If you can run over 2/3 of the world's workload for 6% of the cost, that's a pretty good return on investment. And again, that just is a myth. We should put this on Mythbusters because everybody thinks a mainframe is so expensive. The fact of the matter is it's not. It's expensive to acquire. It's not expensive to own for a period of time. But we always have to prove that, and we do a lot of that with our clients. It's high security, very trusted. Most of the data in the enterprises around the world resides on the mainframe. Most of the transactions run there. The things that I think are especially cool, and especially for people that are not familiar with the mainframe, when there are 20 times as many CICS transactions running every second, every minute, every hour, every day as there are Google searches, that tells you how important it is. And these transactions aren't, looking up the latest term or what, a celebrity is doing. They're actually doing work that matters to business and to our lives. And that's just CICS, not counting IMS and TPF and DB2 store procedures and WebSphere and on and on and on. So there's a lot of very important work, and I liked what Ashok Reddy said yesterday. He's coined this term. I don't know if he coined it, but first time I'd seen it, mission essential. Not just mission critical, but mission essential work. And the other thing is, the work embodied in applications is not going away in the foreseeable future because, and this is a low estimate of 220 billion lines of COBOL that are running, that's how those transactions are written. And then there's PL1 and assembler and CA-Gen and on natural and on and on and on, C++, there's Java. Now there's a lot more Java and modern languages on Z, but that work is not going away. So mainframe is definitely relevant. Now I'm going to talk about 3 examples of things that we think are interesting. How you expose your applications, this 220 billion lines of COBOL or assembler or what have you, to be used in new ways. We're going to talk about cognitive and analytics, and we'll talk about blockchain, which I think is very exciting. So first of all, how do you expose your applications so that they can be used in new ways? And you hear a lot about API economy, API management. Well, the API has to wrap something. And if you've got things that work, that have been working for years, that are trusted, that are secure, but the interface to it is a green screen, you may have some work to do to be able to put a RESTful service in front of it in order to have APIs. So how do you do this? So let me give a little more motivation. Is this how you rent your movies nowadays? No, it's not, because there was a fire sale and you could get some very inexpensive DVDs back in the day when these store closing signs went up. But that's not how you do it. This is how you do it nowadays. There's disruption. There was change. Some folks like Blockbuster did not change in time. In fact, that's been the theme of this conference, built for change. I like that. And so change is required to remain relevant, and so you get it now through the mail or you get it on demand for your movies. And so the question is, a corollary, is this how we ought to be doing Z development these days with ISPF and green on black and 24 by 80 and waterfall development? And I think everybody would say, absolutely not, that's not how it should be. Guess what? That's how 90% of people are still doing it, which is a problem. So, this is how it should be done. And you've been hearing here about what CA are doing in this space, providing modern tools. We have modern tools. There's others out there that have modern tools. If you just saw this, you would have no earthly idea that what it's representing is mainframe code. It's COBOL, it's PL1. That's giving you some information about the interdependencies of things. The thing on the right is visual debugging, and you actually can go in and set breakpoints via the stack and say only break if you get here with this path, not this other path. Cool stuff, and this can be COBOL, PL1, what have you. So this is how you can be doing it, how you should be doing it. All right? Now, the view that we have, and I think is shared by most in the industry, is that the typical topology now, when we talk cloud, is actually hybrid cloud. It's not this binary thing. I mean, cloud, when it first came out, the people get real excited and there's this over exuberance, just like there was when SOA came out or when object technology came out, or go far back as you want. And everybody thinks that's the answer to everything. The fact of the matter is we have to have some balance. And there's actually an answer that is some cloud, and it could be some private, some public, and then some on-prem. And you just have to figure out what the right mix is. But this is the more normal topology that we're seeing companies now sort of settle out, now that they understand the benefits of cloud computing, the benefits of on-prem computing. But to participate in this environment, you have to, for those cloud things to talk to and leverage the on-prem applications, the 220 billion lines of COBOL, there has to be a way to get to it. And that's where APIs come into play. And so we're promoting the notion of an API economy. We have new offerings, one called ZOS Connect, that is just a common way, regardless of whether you're talking to something in Kix or IMS or WebSphere or MQ or DB2, to make it easier to say, okay, here's how you get to these things. And then the front-end developers, the mobile developers, the web developers, all they see is a service interface, API interface. Okay, they could care less, or should care less, where the back end is running. Now, unfortunately, to do this is easier sometimes said than done, because what if that COBOL app is a monolithic with a green screen? There's going to be some refactoring that needs to be done. And whenever you talk change, the reason we have 90% of the people still using stuff that's 30 plus years old is because there is an aversion to change. There's a lot of tree huggers out there, okay? They don't want to change. It's fearful. They're fearful of change. And we've got, you know, these other problems up there. Most work is done manually. They're like, it'll take too long. I'm overworked. They're using these old processes and old tools. And one thing that I think is, we're at the precipice here with staff replenishment. Young people do not want to come in and learn ISPF. COBOL is a programming language. They can learn that just like they can learn Python, just like they can learn Ruby, JavaScript, Node, whatever. It's a programming language. I went to university, went to work for IBM one summer, picked up Kernighan and Ritchie, read it, and wrote 3,000 lines of C code for the point of sale system. That's what programmers do. You can do it for COBOL, okay? But they don't want to do it using ISPF. So we need to give them something new to make it easier to learn the systems and use new processes that is what they would expect coming out of university, because the existing staff are going to retire. And the apps aren't going away, so who's going to support them? So one thing that we did back in June of this year is acquire a company called EasySource that is designed to help expedite the discovery and learning or understanding of existing systems and providing information in a visual fashion so that it makes it easier for experienced developers to see the interdependencies of a change they're thinking about making, but especially also for young people coming in brand new, or you're outsourcing something and the new team has to figure out these millions of lines of code. If you have a tool that helps you visualize it and see the structure, see the flow, it's way, way, way easier, faster, and less error prone. So if you're thinking about making a change, you're an experienced developer. You know that the change is going to impact 9 other places. This tool will have the information to say, in fact, there's 11 places that are impacted. You forgot about those 2. Now, maybe you would have caught it when testing, but why do that when a tool can tell you this by looking at source code, looking at JCL, looking at scheduler information, looking at database schemas, and so basically looking across the system and then giving you impact analysis, telling you where you have dead code, telling you about complexity, and we do trending of all these things. Anyway, it's really cool. We'll help make it easier to modify and then leverage the assets that exist on this platform. All right, and this is not just about upfront understanding and planning and all that, it's also day-to-day, and we have many statistics from our clients using this, which is one of the reasons I said, okay, I can buy this, when the clients are saying, this saves me 90% of the time to do this activity, or my developers are 25% more productive by using this on a day-to-day basis. And so, I'll wrap up this section by saying this is the thing in red, application discovery, and there's actually a delivery intelligence piece where we're providing dashboard and trending information. So you can say over time we've gone from 20% dead code down to 9%. We're meeting the objectives of the goal of reducing dead code, or we've reduced the complexity of this system. One other thing we have is one of the biggest areas of waste, which DevOps, one of the big DevOps principles is to eliminate waste and eliminate work in progress. This kind of comes from the lean area. And one of the biggest areas of waste in mainframe development and delivery is manual testing. There's way less test automation in the Z space than there is in the distributed space. And so, yes, we can tell you to do automated testing, but what if you have 1,000 test cases and we can tell you, based on test coverage information and change set information, meaning you change 3 lines of code, and we can tell you just run those 7 test cases, not 1,000. When you think about manual labor that is involved in running 1,000 test cases, you would never run them manually for a 3-line change in code. And so therefore you can never do small batch delivery, which is another major principle in DevOps. But if we can shorten it by 2 orders of magnitude from 1,000 to 7, maybe you could justify delivering 3 lines of code at a time and actually get into more of a continuous delivery cycle, even if you don't have fully automated test suites. So that's another example of something that we're doing. That one we call cognitive DevOps, because we're applying some insight and knowledge, looking across various pieces of information in the life cycle. All right, but we have a lot of other things, just like just like CA do. And the thing is, our platform is open. You can use some CA stuff, you can use our stuff, you can use open source. And most clients are doing that. They mix and match. It's not all or nothing. All right, second thing that we think is pretty cool is around analytics and cognitive. So the objective, everybody is talking about big data. Everybody's talking about analytics. And so you say, well, what's the particular unique aspect around the mainframe? Well, the unique aspect is 70 to 80% of enterprise data is there. And so if you want to gain the insights that analytics are designed to provide so that you can make better business decisions, more timely business decisions, you need to do it quickly. When someone is doing a transaction, you need to do it in line or in real time, so very quick, soon after a transaction has occurred, not days later, not hours later. And yet, if you're going to do analytics, you want to use all the modern tools, the modern platforms, the modern languages that people are doing it on other platforms. So how do you solve this problem with Z? You make sure that all these things work there. So we have worked with partners like Rocket Software to get Apache Spark on ZOS, and the R language, and Python, and Zementis has got something where you can do inline predictive analytics in your online transaction processing system. So, we started doing something like the Db2 Analytics Accelerator a number of years ago. So that was an early foray into it, where we were doing something where queries that were really complex simply could not be done inline. With this accelerator, it runs some queries that our customers have measured like 2,000 times faster. So you actually can do it inline. But we're not going to solve every problem. So we partner with people, use other languages, other technologies that people can now say, now, do I do it where the data resides on the mainframe, in the transaction, inside the CICS transaction, IMS transaction, or do I move it to a data lake, an ETL, And we've seen statistics that, around 20% of Z MIPS are spent moving data, ETLing data. Well, back to the whole DevOps and eliminating waste, that is waste. You don't need to do it, and now the data is going to be stale. The time it's going to take before you now get the new business insight is delayed, so maybe you lost the opportunity to do the upsell. Or that fraudulent purchase of tennis shoes down in Guatemala, which happened to be the last time my credit card was stolen, is what they told me happened. It's already happened. The credit card company already lost the money. Okay, I don't lose the money because that's one of the benefits of having a credit card. But, why not catch it when it's happening? And you can do that if you can do these analytics things inline or in real time where you can quickly roll back the transaction. So, okay, sometimes ETLing for things, deeper analysis that is more about strategy, okay, fine, do that later. But there's many times when analytics should be done in real time or inline, inside the transaction. And so, just wrap up on this one. We've put, working with Rocket, gotten Spark on Z, but then you say, okay, well, good, it runs there. We've also worked with them to have this very optimized data access layer for both data on Z, vSAM, DB2, what have you, and data off Z. So you then have a federated result set, federated set of recommendations. It doesn't all have to be coming just from the Z data, because enterprise applications are multi-platform. Data is spread across platforms. All right, and finally, let me wrap up with blockchain. I'm not going to ask for a show of hands, but, blockchain is something that a lot of people are talking about, but I suspect if you went out and talked to the general public, they may not have heard about it or have no clue what it really is. The more I learn about it, the more convinced I am that some of the hype that I initially thought was hype is actually probably more likely true than not, such as people asserting that blockchain could be as transformative and disruptive to how business is transacted as the internet was to how information is shared. And you think about how we shared information before the internet, and now how easy it is, and what you have on your fingertips, and bar arguments get solved by somebody doing a quick Google search rather than, 3 days later you find out what the answer is. What about business being much more automated, more secure, more reliable? So I heard this, I'm like, let me think about it, see if I really believe it. I'm getting to the point where I believe it. Now, why? Well, here's $2 reasons why. In just, 3 areas of doing business, you spend $300 billion a year. There's $600 billion estimated loss from global trade fraud. Many more dollar reasons, but and when you get to understand blockchain, it's not just about money, okay? But here are $2 motivating reasons for blockchain. Now I'm not a blockchain expert, and we don't have time to do a tutorial on blockchain, not that I'm qualified to do it, but I want to explain a few things just to make sure we're all on the same page, and then I'll talk about why Z. But there are a number of concepts in blockchain, but here are a few of the most critical ones. One is this notion of a shared ledger. And it's basically a ledger like you write a ledger recording a transaction. And you then record the next transaction, and it's always in a certain state. And, you're not supposed to go back and do whiteout or use an eraser to change something because that might be fraudulent, all right? Well, blockchain is basically the shared version of the ledger shared amongst the people in a business network. They call them members, all right? So this is the chain, and you start from the beginning. It's like the first ledger entry. You get a hash value of it. You have a timestamp, and then the next block refers back to that one, has the same information, hash value, on and on and on. And each time there's a hash value of the entire chain. And this is recertified by all the members, which is what the consensus thing is about, every certain period of time, let's say 10 minutes. So being able to go in and change things across all these members in the network is highly, highly unlikely and very difficult. Not impossible, but very difficult. But that's why they have consensus algorithms that 2/3 plus 1 of the members must certify that the blockchain is a good state every, let's just say, 10 minutes or what have you. The smart contract is what they also call chain code. It's where you enforce the business rules that need to be adhered to when a transaction is occurring, such as, you can transfer money between parties across borders except when it crosses the $10,000 threshold, in which case you have to involve a government agency in the process or something. So that's the code that gets run. And then there's privacy. So only members in a network, in a business network, can see what's going on. But then they have transparency. They can see the things they need to see to make sure their other members in the business network are behaving like they should. So there's a lot more you could say about it, but those are some of the fundamental principles. Now, why, again, versus dollar savings only, if you think about it, this will save time. If you can cut out middlemen, if you can automate the validating of identity, if you can automate settlement. Think about it when you buy a stock. You get back submit an order, immediately it comes back. However fast that browser can refresh the page, it says you just purchased 100 shares of your favorite stock. You now have to wait 3 days before you can sell that stock because there's this settlement period. That's the kind of thing that using blockchain technology could be settled. You could turn around and sell it, let's say, 10 minutes later when the blockchain is certified by all the members in the network. It's going to cut out costs because it's cutting out manual work. This is the whole DevOps thing again. That's the way I like to think about things. Getting rid of waste, getting rid of unnecessary manual processes that could be automated. So many of our business transactions are following, just like our development and waterfall as an example, business processes are following things from the 1800s. Haven't modernized. It's time to modernize this stuff. It reduces risk because it is tamper resistant. They don't like us to say tamper proof, but tamper resistant because of the consensus, because of sharing the stuff across the network. Just like the reason, it's hard to get rid of information with the internet because it gets replicated around and so forth. And it increases trust because there is transparency amongst the members who are participating in the network. And you can see everything. And you can go back and audit because the blockchain is an append-only model. You don't go back and use the whiteout and change something. All right. And one thing I think is important to understand is this is, let's don't do the hammer, I've got a hammer, therefore you're a nail type of deal. Blockchain is not for everything. And the thing that I did not understand early on when I started trying to learn about this, it is not there to replace your CICS transaction or WebSphere transaction or whatever. It is to record the result of a business transaction. Let's think about that as a higher order concept that might actually require 50 CICS transactions to run or what have you, or some DB2 store procedures to run and this and that and the other, and then you record the result if you get to a good state. So it's not trying to do this sub-millisecond type of processing. You think about all the hashing and time stamping and all this stuff, and blockchains get really, really big. Just calculating the hash value is going to take a little bit of time, okay? So it's not for this stuff. Now, let's talk about Z, and we'll wrap up. Why Z? Ginny Rometty, our CEO at IBM, said, and I think the more I think about it, I was like, this is a good quote. Blockchain was built for Z. Or you could think about it, if it was timing had been swapped, mainframe was built to solve the blockchain problem. Why? Primarily, there are a lot of good ilities about the mainframe. Scalability, reliability, all these things, but security. And we have something that we've introduced called the Secure Service Container that is a tamper-proof container that not even someone with system administrator access can go in and alter once it's been booted, once the bootloader brings it up. Now, there have been a few examples where there have been some breaches with blockchain, like somebody got in and changed the value of 1,000 diamonds in one of the blockchain implementations. It was an insider job. The person had root authority or admin authority. So no one outside tampered, but it was an insider. In the case of this SSC implementation, blockchain code is not tamperable. And again, lawyers don't let us say tamper-proof, but it's as close as it can get. And we also have crypto accelerators on and on, so doing a lot of the encryption and all that is going to be extremely fast, but I think the biggest hitter is the security of this platform. And if you're going to change how you do business, change how financial markets work, change how healthcare records are managed, and so forth, you want it to be secure. And final thing, we do have offerings out there. We've put them out there on Bluemix. There's a starter kit for developers so they can just play around, learn how to write chain code and this type of thing. We have a version that is as a service, but is running on Z hardware behind the scenes, not that you care, except for the fact we can claim this is the high security business network because it is using this secure service container technology. So if you have something that you care a lot about and it's important, this may be the implementation you should consider. And of course, we'll be able to provide on-prem things and so forth. And we are one of the founding members of the Hyperledger project, which is out there in open source, because this is not something that should be kept by a given company or something. We need everybody to be doing this if we're really going to change how business is transacted. All right, I'm out of time, but here are just 3 examples, doing modern DevOps, modern discovery to open up the mainframe. We're doing cognitive stuff there with all the modern languages, modern technologies. We're doing blockchain, but this is just the tip of the iceberg. The bottom line is Z is a great platform. It is not the answer to everything. We had a panel yesterday. Some stuff ought to be running on your mobile phone. Some stuff should be running in the browser. But then some things, if they need the quality of service of the mainframe is as relevant today as it's ever been. So, thank you very much for your attention, and I hope you enjoy the rest of the conference.